Well, where would we be in geometry without some proofs? Now, before we begin on this, we're going to be using inscribed angles in proofs, and we've been given here that arc, let me write the little arc symbol, arc QR is congruent to arc ST, and arc PQ is congruent to arc PT. So let's see what we got. Okay, well, here's arc QR right there, and arc ST, and we can see they both have the congruency symbols to them. And then arc PQ, which is here, is congruent to arc PT. We see there also with the double congruency. All right, so they are congruent. And we're trying to prove that triangle PQR, this triangle right in here, is congruent to triangle PTS, this triangle right here. Now, let's see if we can work our way through this. All right, so there's our given statement. And let me put a little arc symbol in there. Arc PQR is congruent to arc ST, and arc PQ is congruent to arc PT. Well, we should know by now that when we start off proofs, that's the given. We're going to start with the given. We're going to end with the proof. All right, so then we could say that the measure of arc QR is equal to the measure of arc ST, and the measure of arc PQ is equal to the measure of arc PT. And now what did we do? We went from a congruency statement to an equal statement, and that should tell me that that's the definition of some kind of congruency. And since we're talking about arcs, well, that's the definition of congruent arcs. Now, let's go another step. Then 1/2 of the measure of arc QR is going to be 1/2 of the measure of arc ST, and 1/2 of the measure of arc PQ is going to be 1/2 of the measure of PT. You get an idea where we're going? We're moving towards proving some angle measures. 1/2 the measure of the arc QR. Let's see, I bet eventually that's going to end up equaling the measure of angle QPR, but we shall see, and we'll move forward with that. Well, let's see, what's our reason here? 1/2 the measure of QR equals 1/2 the measure of ST, and 1/2 the measure of PQ equals 1/2 the measure of PT. And what's our reason for that? Well, that's just the multiplication properties. We're just multiplying every one of those terms of those arcs by 1/2. And then if that's the case, there's our angle. Then the measure of angle QPR equals 1/2 the measure of arc QR. QPR, we'll find that in a moment. And then the measure of angle TPS is 1/2 the measure of arc ST. And then again, measure of angle QRP is equal to 1/2 the measure of arc QR. And the measure of angle TSP is equal to 1/2 the measure of arc PT. Now let's see if we can put some definition to this. So the angle QPR, which is right here, QPR, all right, well, that's equal to 1/2 the arc QPR. Okay, well, that seems okay. And then 1/2 of the measure of TPS, yep, TPS, that angle right there. Well, that's going to be equal to 1/2 of the measure of arc ST, All right. And then we say that the measure of angle QRP. Well, now that's this angle right here. And it is equal to 1/2 of the arc PQ. And then lastly, the measure of angle TSP. That angle right there is equal to the measure of arc PT. And so what's all of our reason for that? I think it has something to do maybe with the inscribed angle theorem. Oh man, this is just so great. All right, well, let's go another step. Well, then we can say that the measure of QPR is equal to the measure of TPS, and we've got our little congruency marks here. One right here. One right here. These two angles are congruent. And then we can say the measure of QRP is equal to the measure of TSP. Let's put that in a different color maybe so we can see it better. So this angle is congruent to this angle. All right, well, I've got two angles that are congruent. Angle, 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 angle. I think I'm getting suspiciously close to an angle, angle, side proof statement, but let's see how we go. All right, well, that's just substitution. We just substituted that. Go back up here. If the measure of 1/2 of arc QR is equal to the measure of 1/2 of ST, and then we said that the measure of angle QPR is equal to the measure of QR, and the measure of angle TPS is equal to the measure of ST. Well, then by substitution, the measure of QPR is equal to the measure of TPS, as well as the measure of angle QRP equaling the measure of TSP. And so, what do we got here? Then we go from equal to congruency. The measure of angle QPS is congruent to the measure of angle TPS, and the measure of angle QRP is congruent to the measure of angle TSP. So I went from an equal to a congruency statement, and we're talking about angles. I bet that's based on, the reason for that is the definition of congruent angles. Oh, yes, it is. Yes, it is. All right, let's see. Well, I've got an angle, angle, and an angle, angle. If I had angle, angle, side, and angle, angle, side, I could prove those triangles. But let's see here. Well, there's a chord, and there's the chord. How about this? Side QR, arc QR. Oh, I need to put that in white. Arc QR is congruent to arc ST. And why is that? What would be our reason for there? Well, congruent arcs have congruent chords. So that means those side lengths are congruent. Well, shazam. I've got angle, angle, side, congruency. So triangle PQR is congruent to triangle PTS. And the reason why? Angle, angle, side. Double, double, triple, triple, shazam.